Hello, everybody, and welcome to the Plant Engineering Webcast, How to Prevent Motor Bearing Damage Caused by VFDs and PWMs, sponsored by Hellwig Carbon Products. I'm your moderator, Gary Cohen, very happy to be with you today on behalf of Plant Engineering. Before we get too far, just a few housekeeping issues. We're going to talk about the webcast console we're all going to be using today. Please type any questions for our speakers in the Q&A widget that's located below the slide presentation. Our live Q&A will start in about 45 minutes. Today's webcast is being recorded, and you'll receive an email with a link to the on-demand event. To download a PDF copy of the presentation and a certificate of completion, use the Additional Resources widget on the right side of the webcast console. Those documents also will be available with the on-demand version of the webcast. And if you're like me and you need to see things a little bit bigger, you can expand your view of the slides by using the icon in the top right corner of the slide widget. A few more tips and tricks just to help you get the most from today's webcast. If you're experiencing any issues with your slides or with your audio, first try refreshing your browser. You can control the volume of this webcast by adjusting the volume on your own computer or by adjusting the volume on the webcast platform. If you're having any technical problems with your audio or with that slide presentation, again, first try refreshing your browser, but if that doesn't work, you can click on Help in the top navigation toolbar for additional troubleshooting steps. If it does turn out you need a technician, just type a message in the Ask a Question box and our tech team will get to you as quickly as possible. Any individual user experience questions, I'm having trouble hearing the audio, I can't see the slides, those will be answered in the Q&A widget below the slide presentation. Before we get into our presenters, first, a quick word from our sponsor, Hellwig Carbon Products.
No matter what industry you're in, Hellwig Carbon is your trusted partner for keeping your motors and generators running smoothly. Whether you are an OEM or doing aftermarket repairs, we help extend equipment life, optimize performance, and minimize downtime with high-quality, expertly engineered carbon graphite solutions made in the USA. Backed by cutting-edge research and groundbreaking industry-leading innovations, Hellwig Carbon delivers outstanding quality, reliability, and performance. With unparalleled service, high-volume production, on-time delivery, and superior quality assurance, you can count on Hellwig Carbon to keep your operations running at peak efficiency. Hellwig Carbon, powering industry with engineering excellence and unstoppable innovation since 1928.
All right, now we get to the good part where I get to introduce our wonderful speakers for today. David Duke is the engineering manager at Hellwig Carbon Products, leading the engineering teams that support, design, and develop electrical brushes, holders, and shaft grounding products. He graduated with a BS degree in mechanical engineering and has more than 30 years of experience in the engineering field. He has experience working on many different mechanical and electrical systems and has successfully completed several small and large-scale products. We also have Admir Karabegovic. He's an engineering professional specializing in sliding electrical contact technologies and motor applications. He brings years of hands-on experience diagnosing issues in rotating equipment and developing practical solutions that improve performance and overall equipment uptime. Admir works closely with OEMs, service centers, and maintenance teams to solve complex motor challenges across a wide range of industrial applications. He's committed to advancing best practices and sharing real-world insights. Admir, I am now happy to turn things over to you.
This is Admir Karabegovic. Good morning or good afternoon, wherever it is you're logging in from. And we'll just go ahead here. This is our agenda for today. We're going to talk about the prevalence, costs, and the cause of the problem, the voltage thresholds, detection and measurement techniques, types of mitigation systems, how shaft grounding works, considerations when choosing a shaft grounding product, effectiveness over time, contamination, installation, maintenance requirements, and then at the end we'll do a Q&A. So what's the leading cause of electric motor failure? Well, you have two main leading causes that is the stator windings and the bearings. Now, majority of the motor failures will be due to bearings. The 51% is both electrical and mechanical bearing damage. So the typical cost of bearing replacements, it's certainly not cheap. Bearing replacements can range from anywhere from $1,000 to $10,000 for an industrial motor, depending on the size. And that's not considering the hidden costs, which is access to the motor and generator. There's a lot of motors and generators that are in environments that are very hard to get to, need specialized equipment to get out. And not just that, but the major cost is the downtime, the loss of production. So what motors are at risk of electric bearing damage and why? So any AC motor that is run off of variable frequency drive, a VFD, and any DC motor that's run off of PWM, a pulse width modulated drive, creates a common mode voltage that couples to the motor shaft. So this common mode voltage seeks the path of least resistance, and that'll typically be through the motor bearings. So these discharges can quickly and significantly over time reduce the life of your bearings. Basically, we're electrically discharging discharging, machining that raceway and ball bearing, causing fluting, frosting, and pitting. There is another problem called circulating currents that can also occur. And that typically happens on larger frame motors. As motors get larger, the complexity of the motor design increases, and typically anything over 100 horsepower and above. And these discharges are very different from common mode discharges and must be dealt with separately. So what is common mode? On the left here at the very bottom, we show an imbalance in the AC waveform from a VFD, which create this common mode voltage. This common mode voltage then gets parasitically coupled to the motor shaft and then discharges through the bearing to ground. And similarly on PWM systems with DC motors on the right over there, a similar thing happens where we have an imbalance in the waveform there as it relates to the motor neutral. And this again creates this common mode voltage, which gets parasitically coupled to the shaft and then tries to find the path to ground, which will be through the motor bearings. Here are a few trends in the VFD industry. So most of the VFDs that we see in operation today have a runoff of a carrier frequency between 4 and 8 kilohertz. Some drive manufacturers are pushing those carrier frequencies much higher. We've recently started working with a few different companies that are pushing up the carrier frequencies up to 60 kilohertz. We've done some testing here at Hellwig in our test lab, as well as out in the field. And what we see is that with that increase in the frequency of the carrier frequency, we do see an increase in shaft voltages. Just to kind of give you an idea, so generally speaking, anywhere from 48 kilohertz for the carrier frequency I see out in the field, as low as 2 to 3 volts peak to peak on the shaft, up to maybe 20 volts. That seems to be the range. But on these newer drives with much higher switching frequencies, we see shaft voltages up to 60, 70 volts peak to peak. So why are the bearings being damaged? So as discussed, the VFDs induce this common mode voltage on the motor shaft, as pictured on the right. This voltage and current passes from the motor shaft to ground and usually discharges through the drive-in bearings. So these discharges cause the pitting, fluting, and eventual bearing failure, which lead to costly repairs. So accumulated voltage obviously seeks the path of least resistance to ground. And this often, again, happens right through the ball bearings. And generally speaking, discharges greater than 3 volts will cause bearing damage. So we're going to discuss the ESA shaft voltage thresholds. The general guidelines are anything under 3 volts is generally considered acceptable. We have done a tremendous amount of testing here at Hellwig, and we've seen on some motors, depending on the size, anything at 2 volts or over, we've seen cause bearing damage. Going back to the ESA shaft voltage thresholds, 3 to 6 volts, the bearing grease is starting to break down. And as that bearing grease breaks down, it carbonizes, becomes higher in friction as well as resistance. And then anything over 6 volts, arcing can certainly occur. So if the magnitude of a motor's high frequency shaft voltage is below 3 volts, which is approximately the threshold for commonly used grease to break down, the motor should generally be free of bearing currents. A range or level of the referenced high frequency wasn't bearing lubricant, and depending on the type of bearing lubricant and the clearing between the race and ball bearing. The source is the ESA Update Technical Service Committee Bearing Currents Task Group Summary Report by Tom Bishop. So here are the common signs of bearing failure. The symptoms you'll typically see are vibration, overheating, noise, and burnt grease. There's been a lot of places I've been to, a lot of plants that sometimes you just walk into the door and you hear those motors whine, and you know right away that that's the bearings. So you do this often enough, you get to understand the pitch and the frequency of those whines, and you can relate it back to, okay, yeah, that bearing is shot and needs to be replaced. And again, the results are frequent downtime, loss in production, and very costly repairs. So what does electric bearing erosion look like? Electrical discharges often create a fluted pattern and pitting in the raceway, frosting in the ball bearings, and burnt grease. Damage to the bearing from electrical erosion can cause noise, vibration, and premature bearing failure. So in the pictures below, frosting would be your early signs, which would be the pictures in the middle there. And then over time, as we get more discharges and the bearing deteriorates even further, we get a washboard pattern, which you see on the pictures to the far right and the far left. So how is bearing damage found? It's fairly simple. You just cut the bearing, and it can always be done at an ESA accredited service center. And what you can do is once you cut those bearings, take a picture of the raceway, and you can send those pictures to us to give our expert opinion, and we will certainly work with you to troubleshoot the issue and provide some type of bearing protection kit or a mitigation device. So detecting shaft voltage and current. There's a couple different products out there. You can use a Rogowski coil. It can be quite difficult to utilize, especially if you're out in the field. You can use an oscilloscope with an attachment similar to a shaft voltage tester, like a carbon fiber based tester, and our own Hellwig Carbon bearing protection kit probe. We would not recommend the use of a multimeter, just because the way the multimeter takes in the information, it's going to give you misleading results. So this is our bearing protection kit probe. It's a easy technician's level device to check for shaft voltages. And here are the features of the BPK probe. It has a very easy to read LCD screen. It has a simple pass-fail operation and can also detect ground errors, which is helpful in cases when you're troubleshooting these types of applications. We know ground is extremely important in motor applications. We do have embedded silver graphite grounding brushes and a durable silver graphite testing tip. So our kit has 2 silver graphite sliding contacts, one that is the sensing brush that senses the shaft voltage, and the second one can be activated to act as a shaft grounding brush. And it's fairly easy to use. You touch the BPK probe to the shaft, hit the rocker switch, and within 10 to 20 seconds, you will get a result. Now you can also pair that with a oscilloscope. So we provide an oscilloscope with our BPK probe, or you can use any third-party oscilloscope, and you can see in real time what's happening on that shaft. So many customers ask, why measure voltage and not current? So measuring voltage is just much easier than measuring current out in the field, especially. You could measure current with a Rogowski coil, but again, it's difficult to use in a perfect test lab setting. It would be preferred, obviously, but once you're in the field, it makes it a little more difficult. And voltage and current closely match each other in bearing discharges. As you can see, the waveforms down here, the current is in blue and the voltage is in yellow. And when we see a discharge, we see it both on the voltage and the current. So we know that measuring voltage is a good way to proceed when checking for common mode voltages. So there are several different ways to mitigate these discharges. There's signal conditioning and side wave filters. We've worked with a few companies that make these products. They are different in the way that our products work, but they do help. Inductive chokes is another one that seems to help tremendously, reducing the amplitude of the discharges. Bearing discharge mitigation continued. So mitigation of shaft voltages, you can use an insulated bearing. It is very expensive. Sometimes it comes with significant lead times. It certainly does help with circulating currents, but if you're just using a insulated bearing, you'll help with the circulating currents inside the motor, but you still have the common mode voltage to take care of. You can use a carbon fiber ring. Generally speaking, they're much higher in electrical resistance. The fibers do wear over time, and they can be difficult to install or retrofit a motor out in the field. And then we have our Hellwig carbon bearing protection kits. These are made from a specifically designed silver graphite sliding electrical contact. It typically reduces the discharges to less than 1 volt. And it's quick and easy to install in the factory or in the field. So how does a bearing protection kit work, or BPK? So the silver graphite brush provides the least resistance path to ground. The positive spring force keeps the brush in continuous contact with the motor shaft. Each one of our kits comes with a constant force spring or a coil spring to give tension on that silver graphite brush to keep continuous contact with that rotating shaft. The silver graphite grade has very low coefficient of friction, very good lubricity, so we have very little mechanical wear, and since it's basically a dead short to ground, there's little to no electrical wear. Generally speaking, we get 10 plus years under typical conditions. We actually have a kit in our test lab that we've been running over a decade now, and it still has very good life on it. So the engineered silver graphite material is self-lubricating and doesn't need any kind of maintenance. And these kits do handle high frequency discharges as well. We should note that our BPK or any bearing protection kit device won't properly function if the motor ground is not properly set. So what are the considerations when choosing a shaft grounding device? Here are the couple things that I look for. Lifespan. You could have, something that works really well, but if it only works for a few months, is it really worth it? It's got to perform in high frequencies. It's got to perform well in contamination, hazardous environments. It's got to be easy for inventory management, ease of installation, customization, and as well, the company should be able to provide customer support. We've done a lot of testing in our test lab here at Hellwig on many different sliding electrical contact applications. This one here, we tested the electrical performance of the silver graphite brush over time. So we start here on the left. We have a completely brand new silver graphite brush on that shaft. And as you can see, we're at 48 millivolts, 0.048 volts, which is certainly in the safe zone. Again, anything under 2 to 3 volts would be considered safe. At 25% of Vorn, the silver graphite brush max voltage came out to 120 millivolts. And at 50% of wear, we're still in a very good range at 80 millivolts. This is another test that we conducted comparing a carbon fiber solution with our silver graphite brush. This was done on a Marathon 1.75 horsepower, 1716 RPM, 143T frame inverter duty motor. We conducted this test over a period of about 5 months. I think we went over 5 months. As you can see, the silver graphite performance is flat. You know, we're under 1 volt on the shaft voltage. The carbon fiber ring starts at about 1.5 volts, which is in the safe zone. But after about the 4.5 month mark, we do see it increase quite a bit. And that is due to the wear of those carbon fibers. They don't have any positive spring force. So as they wear, you will get contact resistance and a gap there. And with any kind of electrical system, you know, contact is king. We want to continuously be making contact with that rotating shaft. Now, high efficiency motors. Obviously, new motors with higher switching frequencies require a very low impedance. So we did test our silver graphite brush up to 1 megahertz, and we compared it to the carbon fiber ring. As you can see, the carbon fiber ring initially from the start had a much higher impedance compared to our silver graphite brush. Our silver graphite brush the impedance does increase slightly once we get towards that 1 megahertz range. And this should be well within any motor application. So, contaminated environment performance. We need to make sure that our BPKs or any bearing protection kit works well in an environment where there is a lot of contamination, be it a paper plant or steel plant, things like that. Here you can see a couple different images of our bearing protection kit with a lot of oil grease. And the middle one there is from a paper plant. As you can see, that motor is pretty gunked up. So again, we do a lot of testing here. We did a test with grease using the carbon fiber ring as well as the Hellwig bearing protection kit. We started with running the kits on a clean motor with no grease, and the carbon fiber ring had about 1.2 volts peak to peak on that shaft. So you're in the safe zone there. Once we started introducing grease into the pathway of that fiber ring, the shaft voltages increased significantly to 21.2 volts peak to peak, which is certainly causing bearing damage. With the Hellwig bearing protection kit device, we started out with no grease and we were at 40 millivolts, very safe. Once we started adding grease, we were still in a very safe zone, and that's due to the positive spring force. Again, we use constant force springs or coil springs to keep tension on those silver graphite brushes to ensure that there's very low contact resistance. So we ran this test for quite some time. We didn't see an increase in the shaft voltages with our kit. So what we did is we applied about 4 times the amount of grease, more than what you would typically see in almost any application. And we were able to increase that voltage on the shaft to 200 millivolts, still within the safe zone. So hazardous environments. There are applications out there where these kits need to be capable of C1D2 and C2D2 certifications. So if you are operating in such an environment, what I would recommend is to go back to the motor OEM and tell them that you want to equip the equipment with a bearing protection kit device. We have gotten certification through an OEM. Hellwig does not provide this certification. This is something that, again, the end user will have to go back to the motor OEM, and the motor OEM will need to certify that specific motor to be used in a C1D2 or C2D2 certification. But we have gotten approval through one OEM, and that leads the way for other OEMs to get additional approvals as well. So inventory management. Obviously, you don't want to have to stock hundreds of different kits for hundreds of different applications. With the Hellwig BPK, one size fits majority of shaft sizes. With a carbon fiber ring, I believe it is any 1 millimeter change in the shaft diameter requires a new kit to be purchased. Whereas with our kits, we have 4 or 5 major kits, and each one can operate on a fairly wide range of shaft diameters. We're going to talk about the ease of installation and mounting options. So how easy is it to install this solution, and how much flexibility do we have in mounting? This is something that a lot of our end users came to us and challenged us on. And we did develop several different mounting options. Our Hellwig BPK offers an easy multi-fit brackets, drill and tap right into the motor frame, or we also have axial mounted kits as well. The easy multi-fit uses existing motor retainer or perimeter bolts to mount the Hellwig BPK, similar to the picture on the right there. So basically you would undo one of the motor bolts, and you would slide that bracket in, tighten it up, and then there is a little red tab on our actual bearing protection kit, and that is to set the height. And then once everything is set, you release that tab, and that silver graphite brush will eject and hit the shaft, and then that motor is protected. So versatility for installs, motor shops, and harsh environments. We do work with OEMs. If you are purchasing a new motor, you can always ask the OEM to equip the BPK on their end before sending it to you, or you can give us a call and we can help you with retrofitting. Here are a few different types of our bearing protection kits and different types of installs as well. The bearing protection kits are UL recognized, and the certificate number is E485288. As you can see, there's a couple different ways of installing these kits. The far bottom right picture, we have a motor with a small stub shaft where we cannot go axially because there just isn't enough space, in which case we did develop a bracket where we can go axially on these kits. The other one, or radially, excuse me. In the other kits, some are open concept, other ones with the red tabs are closed. Those are good for use in contaminated environments. So if you have a lot of oil contamination or things like that, that red top there doesn't allow anything to be introduced into the kit itself that could seize the brush or cause issues with the spring. These kits are installed outside of the motor, and some motor manufacturers also install them on the inside of the motor as well. Here are the installation recommendations. So the brush should ride perpendicular to the shaft. We don't want the brush to ride at an angle. That'll reduce the net downward force that spring gives and reduce the PSI. So you're gonna lose some level of contact there. So make sure that that brush rides perpendicular to the shaft. The kit should be as close as possible to the bearing. The brush track should be free of keyways, scratches, nicks, or defects of any kind. If it's a painted surface, you have to make sure to remove that paint because that paint is dielectric. And we want to be able to touch raw stainless steel shaft. So if there's any kind of paint on there, please remove that before applying our kit or any bearing protection kit for that matter. The ideal shaft surface finish should be somewhere between 8 and 63 RMS. All of the motor OEMs are in that range, so we are good there. It's possible you have a motor out in the field that's been beat up. If you have a rougher surface finish, that could increase the mechanical wear rate of our kit. So something to keep an eye on. You don't have to use any external lubrication. The silver and the graphite is right in the brush itself. It's self-lubricating. There's no need to apply any silver epoxy on the shaft like you might have to with the carbon fiber solution to reduce the contact resistance. Again, the silver is right in the brush itself. And per electric motor industry standards, insulated bearings are recommended on the opposite drive ends for motors above 100 horsepower. Circulating currents are certainly another issue that can cause bearing damage. It is separate from common mode and needs to be addressed separately. An insulated bearing on the opposite drive end will fix that, and then you equip the drive end bearing with a bearing protection kit device. So we previously talked about surface finish and as it relates to the brush wear. So again, shaft surface recommendations should be between 8 and 63 microinches. And in that range is where most motor manufacturers are. So the graph to the right over there shows you that the wear is minimal at these shaft finishes. Once the shaft finish gets rougher, obviously the wear of the kit will increase. There are ways to mitigate this. One would be obviously to get the shaft surface finished back to an acceptable range, or we could reduce the spring force slightly to reduce the mechanical wear rate without creating issues with the electrical performance of the kit. So there are a few things on our end that we can do in very tough applications. So if that is the case for you, please don't hesitate to contact us. And we can certainly make a custom kit for you, potentially with a custom grade and or adjusting the spring force on our kits. And we're going to go to maintenance here. Again, reminder, remove any corrosion buildup on that shaft if the motor has not been in use for an extended period. So there are applications where motors sit idle for extended periods of time and oxide rust will build up on that shaft. Before you apply a bearing protection kit, what I do is I just go in there with a rubrite or a cleaning stone and just clear a path for that brush to ride on. If there are other applications where that oxide is on there continuously, in those applications, we can go with a different grade that has a little bit more cleaning action, and or we increase the spring force of our kit to reduce the contact resistance. So there's a couple things we can do in tough applications. Shaft voltage should be checked periodically with a device like our BPK probe. What I tell customers is just your PWMs twice a year. and check the brush wear periodically. Typically, the brushes will last more than 10 years. In very rough applications where there is a lot of contamination, a lot of volatiles in the atmosphere that can attack metals. In those applications, we see maybe 3 to 4 years of life, but we can certainly do things to mitigate that with our product. So again, if you have a tough application, it's not your just run-of-the-mill AC motor application, or it's in an environment that's very corrosive, please give us a call and we will work with you to come up with a recommendation. All right, I think we can go to the questions and provide some answers for them.
Fantastic job. Thanks so much for all that great information. You get a little breather now. As a reminder for everybody out there, you can type your questions for our presenter in the Q&A widget below the webcast presentation. We'll get to as many questions as time allows, but know that anything we do not get to today will be posted online at www.plantengineering.com. Also, remember to download a certificate of completion and or a copy of the presentation. Use the additional resources tab on the right side of the screen. All right, guys, I gave you about 30 seconds to take a breath. You ready to jump into the Q&A here?
Sure. Yeah, I think so.
Well, we'll see. All right, let's start with, can you share specifications for your BPK products?
Yeah, sure. So we can send out any specifications. Just need the contact info, and we'll send out what do we have. I'm not sure what specifications they're referring to, but we do have a lot of data on life and or impedance or resistance. So we can share that depending on the application.
Perfect. What is the lifespan of the silver graphite brush?
Yeah, so the lifespan, like he said, is usually over 10 years. It does vary, obviously, depending on surface finish, which we showed that chart, but it also does vary on surface speed. So we can help calculate that based on what your surface speed is, meaning the diameter of the shaft and the speed that it's turning at. And so we can go through and calculate the life based on those variables.
Got it. Can bearing damage be identified without cutting the bearing?
I don't believe so. You can identify the bearing has damage, but I don't think you can determine if it's from electrical or mechanical unless you do cut it and inspect it directly.
All right. What is wrong with using a multimeter? Can you guys explain?
Typically, multimeters have averaging systems in it. A lot of these common mode voltages are at a high frequency, and it typically will not pick up those high frequencies because it's trying to average the voltage over a certain period of time.
All right. We will go with, if the motor is not inverter duty, but still we install a VFD on it, will it damage the bearing? And then if it will, then what are some different solutions to prevent that bearing from damaging?
I guess some thoughts on that one.
Sorry about that. I had a hard time hearing you there. What was that?
Oh, it's just Admin. Do you have some thoughts on that one?
I think it can certainly still, especially if it's not rated for inverter duty. There was an application a few years ago where a customer purchased a bunch of motors that weren't inverter duty rated motors, and they didn't have bearing protection kit devices, and they failed rather quickly running off of variable frequencies drive. So make sure that they are inverter duty rated. So yeah, it can certainly cause issues. Yes.
Regarding the Hellwig Carbon bearing protection kit, can they be installed on submersible motors or water wastewater pumps?
Yes, they can. So we've done extensive testing here where we've submerged them and ran performance tests, and they do perform very similar to when they're just in the air. So yes, they will work underwater along with other contaminations like grease or transmission fluid.
All right. How do line or load filters, chokes, etc., change shaft voltage and bearing wear damage, if at all?
The
So it does lower some of the frequency
I'm
peaks.
sorry, go ahead.
I was saying it does lower some of the high frequency peaks, but it doesn't necessarily get rid of all the common mode shaft voltage. So we'll bring it down some, so they work fairly well together, but typically still need a type of bearing protection mitigation kit.
Admir, did you want to add something there?
Yeah, no, we've done a lot of testing. We partner up with a company. Anybody that wants to have any more information on this and our test results and things like that, we're okay with sharing a lot of that information. Especially considering like inductive chokes, we've done a tremendous amount of testing in our lab, and they do work well. They do reduce the shaft voltage, but they don't eliminate them. So let's say you have 15 volts peak to peak. You put an inductive choke on, you might have 5 volts peak to peak. So there is a reduction there, but you still need some kind of bearing protection device to run that voltage to ground.
Got it. Can common mode voltage current cause stator winding failure, or does it only cause bearing damage?
I have not seen or heard a case where it causes stator winding failure. Again, it tries to find the path of least resistance, which will typically be through the bearings. So the shaft voltage saturates that shaft, and then the closest part to ground would be your bearings. Could it happen? I suppose, but I don't think it's very likely.
Is the BPK grounded through the motor bolt?
Yes. Yeah, so the BPK is grounded through the motor case, and then that case needs to be properly grounded also in order for it to function correctly.
All right, a longer one here. Does an oil lubricated bearing system with the liquid oil in contact with both the bearing and the shaft, rather than greased bearings, eliminate arcing by providing a ground path from the shaft to the motor casing?
Can you repeat that question again?
I thought it was a longer one. All right. Does an oil lubricated bearing system with the liquid oil in contact with both the bearing and the shaft, rather than greased bearings, eliminate arcing by providing a ground path from the shaft to the motor casing?
I don't think we've done any testing on that. I don't know if you have anything else to say about it, David. I'm not sure on that one.
Yeah, I guess it just depends on what the resistance would end up being through that bearing, but typically not. Typically the bearing balls get very close even if there's an oil film, so a lot of times they can arc through that film.
Can these work with motors that have a gearbox mounted directly to the faceplate?
So they can, but they can. It just we'll have to find anything that's close coupled or direct coupled. We'll need to get it on that motor shaft another way. Sometimes we can install the kit on the inside of the end bell or on the opposite side. So we have to get a little creative, but it can certainly be done.
Got it.
The thing to say is we have a lot of custom kits and a lot of options for different mounting locations and directions. So if you do have a specific application, we can help out possibly with a custom kit.
Perfect. Before we move on, I'm going to go ahead and push you to this slide. So if you need our speaker's contact information, David or Admir, it'll be up there for you. Also, just as a reminder, if you want to ask questions, use that Q&A widget below the presentation. We'll get to as many as we can. All right. You say these bearing currents come from imbalance on motor neutral. What is motor neutral?
So it's basically the return path. So when you have an imbalance in the three-phase AC waveform, you try to have it such that it zeroes out right at neutral. If it does not, there's going to be that static charge that sort of just is there, and then it gets coupled to that motor shaft. And then obviously over time we'll go through the bearings to ground.
Perfect. Can the BPK be installed on vertical as well as horizontal motor applications?
Yeah, the direction doesn't matter mounted on any of them. Again, we have a constant force spring, so it puts a constant force on no matter which direction it's mounted. So gravity has little effect on that force.
What product do you recommend for a very dirty environment that may cause the brush to get stuck in a standard brush housing, resulting in loss of connection with the shaft?
So we do have one of our stock kits, the BPK SB. That's a sealed version. So it has a little red top on it. It's completely sealed. The only part of the brush that you see is the part that sticks out at the bottom that contacts the shaft. And those do very well in contaminated environments. If we need to do something custom, we can certainly do that, but it's sort of that 80-20 rule. That BPK SB will work in 80% of all contaminated environments. Yes, there are some applications that get really caustic and we need to apply a custom solution. But generally speaking, the BPK SB is what I would recommend for any environment with a lot of contamination.
Got it. Are these in lieu of shaft grounding rings or used in addition to?
Typically in lieu of, yeah. So we would use this instead of a shaft grounding ring or shaft grounding ring.
Let's see. Explain further how the brushes are self-lubricated.
So we make our carbons, any carbon grade is, you start with powdered metals as well as graphite, you have a binder. So the graphite itself, it has a lot of lubricating properties. So when we run any kind of graphite component on a rotating shaft, it deposits a film or a patina. And that patina reduces the coefficient of friction and helps reduce the mechanical wear rate. So it's really just the ingredients in the brushes themselves. For example, in applications where these things are operating at, say, altitude, like in aerospace applications, there are lubricants or after treatments we add to the brushes to be able to film and reduce friction at that sliding interface there.
All right. What are the advantages of a bearing protection kit over using inductive absorbers?
Using inductive what?
The advantages of a bearing protection kit over using inductive absorbers.
I think, like we said, I think the inductive absorbers don't necessarily get rid of all of the common mode voltage. So typically we would recommend using both. Our system basically brings that shaft voltage to 0, so there's no chance for any arcing through any bearings or transmission.
Yeah, to add to that, especially if you have motors that are critical to your operation, using an inductive choke coupled with a bearing protection kit will probably give you the best insurance.
Perfect. Great questions coming in so far. Please keep them coming. We got about 10 minutes left in our Q&A here. Do inverter duty motors have bearing protection built in?
So many times they do. I believe the end user probably has to request it from the OEM. I know we work with a lot of different OEMs that stock our kits there, and they do equip the kits before they get sent out to end users. So yes, it can be done, but I do believe you have to request it.
All right, I got a multi-part question here, so I can reread it if you need it. On bigger motors over 500 HP, would you run more than one grounding brush? And if so, where would you place them? Second part of the question, which I can give you in a second. Do they need to be in each end of the motor or the same end? And if the same end, do they need to be 90 degrees apart? You want me to read the first one again?
Yeah, please.
Okay, great. It was a lot. On bigger motors over 500 horsepower, would you run more than one grounding brush? And if so, where would you place them?
I just horsepower alone doesn't dictate the number of brushes. If it's a critical application, I would, just because the cost of these kits is minimal to the cost of having to repair a bearing. And as far as applying them, we typically recommend applying them on the drive end. And if you're going to apply more than one kit, say you have vibrations or it's a critical motor, in those cases, we do recommend multiple kits. I would recommend not putting them, so vibrations run in a plane. So if you equip a shaft with a bearing protection kit at 12 o'clock and 6 o'clock, if that vibration hits at that plane, there's very high potential that both of those brushes will lift off for a second, and for that second you are unprotected. That's why we always recommend to apply the kit, say at 12 o'clock and a 4 o'clock position, so they are outside the plane of vibration for each one. Hopefully that answers it.
I'm very impressed that you got to both parts of that question. Well done.
Thank you.
Let's go with, are grounding straps needed when using the Hellwig kits?
So really the only time you need grounding straps for our kit, some of our stock kits do come with bolts, so you can drill and tap into the end bell, in which case, our kit is directly connected to the motor. You don't need a ground strap, but we do provide our kits with VHB tape and some kits with 3M dual lock. Obviously those are dielectric. If you're going to use those, then yes, you have to run a ground wire from the body of the kit to a bolt on that motor.
All right. I have a motor pump assembly that's covered but still susceptible to weathering, rain, wind, and sun. What is the lifespan of your product?
So what I would tell you is, contact us directly. We do have a lot of information about different tests we've run out in the field that'll give you the life on those kits out in the field. If I recall correctly, I think the shortest lifespan we had was about 2 or 3 years on an application that had a tremendous amount of issues. But generally speaking, they last a long time. Again, we have little to no mechanical wear there because of the lubricity and low friction of our kits. And there's little to no electric wear because, again, it's basically a dead short to ground. If you have amps there, there's something else going on. There's a completely different problem. So I would tell that individual, contact us directly, let us review your application, and we can give you a better estimate on kit life in your application.
Yeah, the other thing I'll say about that is that generally they create their own track. So if it's running and if it's raining or whatever, if it's continuously running and you're doing that, the brush will create its own track and continue to ground. The one issue we do see, though, is if you do shut it off for an extended period of time and it's outside and the shaft starts to get corroded, we do usually require some type of cleaning on that shaft to make sure you continue to have a good ground.
Got it. Can you install the grounding kit on gearbox shafts?
Absolutely.
Absolutely, yeah.
Yeah, and what we've seen as well out in the field, I recall an application where the motor had an insulated bearing on both the non-drive end and the drive end. So that helped with the circulating currents. There was no kit for the common mode, and it was equipped or it was coupled to a gearbox. And actually, we saw electrical discharge machining on the gears of that gearbox because we fixed the issue here, but it just went down the shaft to the next component. So it's certainly important to do a full electrical analysis of your entire system there, especially if you got stuff that's coupled to other things and things not unlike that.
Got it. What type of maintenance do these kits require?
Not a lot in general. I think just periodic inspection of the brushes themselves to see how they're wearing, but other than that, not really anything.
Simple. All right. Do they need to be seated on the contour of the shaft?
They do not. No, not to start with. So they'll seat themselves over time. But what really happens is at the very beginning, there's sort of line contact on the shaft, and that creates a very high pressure, which actually makes a very good ground. So as it wears, it'll eventually seat itself in, but for that whole time, it's protecting the motor.
Got it. We have a little. Oh, sorry. Go ahead.
Yeah, just to add to that, because I know a lot of people might come from the DC motor side where we're talking power. In those applications, you certainly do want to, seat the brushes in. But in static grounding applications, you don't need to. You can just equip the shaft with the kit and let it run.
Perfect. We'll have a little less than 4 minutes, so we're closing in on the end here, but we'll see if we can get a couple more questions in. Are the kits refillable, or do you replace the entire kit?
And in general, it depends on the size of the kit. So we have some that can be replaced. The brush can be replaced as it wears out on the sort of larger size versions. But the other ones, there you have to replace the whole kit.
Got it. Did you want to add on there?
No.
Okay, perfect. Is shaft grounding always necessary on VFD-driven motors, or only in certain applications?
I would honestly, for the cost of these kits, I would, if I was running a plant, I would equip everything with a bearing protection kit. I know that seems a little biased because we're the ones selling them. But generally speaking, this problem of common mode happens on, it's physics, and we can't change physics, right? So any motor with a runoff of variable frequency drive is going to have this problem. The question you have to ask yourself is, to what degree? If you're running at a much lower carrier frequency at 4 kilohertz, you might get away for a year or two maybe, but those bearings are being damaged. So you just have to kind of, put it on a scale. What do you want to do? There's going to be an eventual failure. It's possible you're okay with 2-3 years of life on this motor, and you're just going to toss it and put a new one in. But generally speaking, these kits cost only $100 to maybe $300. So I would just equip the bearing protection kit and know that your bearing is being protected.
Perfect. I'll see if I can get 2 more in here. How does switching frequency and carrier frequency influence shaft voltage and mitigation performance?
Yeah, so like Admir said, a lot of the higher the carrier frequency or switching frequency, typically the higher the shaft voltage that we see. Also, though, it also increases the frequency of that shaft voltage. So that requires obviously a higher, better impedance brush, which is why we developed our brushes to work at very high impedance numbers, like we saw in the chart in the presentation.
All right, we've worked you guys very hard. This will be the last one, I promise. What are the advantages of a BPK over a sine wave filter?
David, you want to take this one?
I'm not sure if we know what the advantages. I think, once again, it's very similar to the chokes and that type of devices where we're guaranteeing basically that the shaft voltage goes to 0. Where those, you're trying your best to filter that sine wave to get it to get rid of the common mold, and it's also very difficult to do. So I think this is just a guarantee that that shaft voltage gets all the way down to as close to 0 as possible.
Got it. Everybody, thank you, everybody out there, for all the great questions. Really robust Q&A. Excellent. David, Admir, thank you so much for providing all this information for us. Great presentation.
Yeah, thank you so much for having us. Appreciate it.
Absolutely. Unfortunately, that's all we have time for today. Now that we are just about done, we're not quite done yet, please take a moment to answer a few questions on our exit survey that's going to pop up on your screen. We use these answers to help make improvements to our webcast program. Finally, on behalf of Hellwood Carbon and Plant Engineering, thanks so much for joining us today. We'll see you next time.